Write down the topic. Write down the topic. Movement of inertia. Write down the topic. Movement of inertia. Movement of inertia. Movement of inertia. Right? Movement of inertia. Right. The moment of inertia is the symbol is capital I. Capital I. It is like a inertia that it is like same as the inertia which we discuss in linear motion. What is the inertia? In linear motion, the inertia is the mass of the body. Mass of the body is the inertia. That is the uh, resistance to the motion. Like that, the in rotational motion, the inertia is the moment of inertia, right? It is the resistance to the rotational motion, right? Okay, write down. The mass of the body is the mass of the body is the mass of the body is measured its reluctant to measure its resistance to any change any change of linear motion, any change of linear motion, any change in linear motion, corresponding the corresponding property for the rotational motion, the property corresponding property for the linear motion, for the linear motion, for the linear motion is called the moment of inertia. Is called the moment of inertia. Right. Okay. What is the moment of inertia? Let's take the mass of P. P particle, it is simple mass, uh, simple mass. And it rotates with the radius from the O center, right? It's rotate. We can simply say I equals the moment of inertia equals mr square. It is the theory. I equals mr square. When the simple ms rotates with the r distance, with the r radius of uh, r radius, the rotational motion, the I equals mr square. I equals mr square. Write down. Write down. Uh, let capital P particle. Let capital P particle having a mass simple m, having a mass simple m, having a mass simple m, rotate in a circular path, a circular path with radius simple r, with radius of simple r, radius of simple r. Then the moment of inertia then the moment of inertia about the center capital O is center capital O is given by right. Draw this one and write down. I equals mr square. If it rotate, we can simply say I equals mr square. It's a theory, right? I equals mr square. Okay, write down. So find out the dimension of the eye. What is the dimension of the eye? Dimension of the eye. I equals, yes, I equals ml square. I equals ml square. mr mean l square. I equals ml square. Right? What is the unit? Unit. We can simply say the basic unit is the kg m square. Kg m square. Basic unit is the kg m square. Kg m square. And the another units can be taken gram cm square. Like that. Right? Okay. Okay. Then write down this one. Write down this one. And write another topic. The moment of inertia of system of particle. Moment of inertia of a system of particles. Moment of inertia of a system of particles. Right. System of particles. We are discussing the system. System. Right. When we take the system, the moment of inertia can be taken as the summation of the I can be taken as the summation of the mr square. Like this. When we take mass system, the m1 mass located from the simple R1, M2, R2, M3, R3, M4, R4. When it rotates, we can simply say I equals M1 M1 R1 square, M2 R2 square, M3 R3 square, M4 R4 square. We can simply say like that. Then we can write I sigma I equals 1 to n. I equals 1 to n mi ri square is the capital I. Okay. Write down the topic, moment of inertia of the system. Then write, when consider when consider An object which an object which rotates around 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 o axis and having symbol m1 comma symbol m2 comma symbol m3 comma symbol m4 comma uh, dot three dots situated at a distance m1 m2 m3 dots three dots situated at the distance R1, comma R2, symbol R1, comma symbol R2, comma symbol R3, comma symbol R4, three dots. From the axis, then the movement of inertia, movement of inertia of system of particles, is okay. Draw the draw this system. We take the M1, M2, M3, M4. There are so many particles. When we consider an object like this, it's having a lot of particles. Therefore, we cannot calculate. That's why we simply write the sigma. Sigma means the summation of all particles. Summation of the all particles. That can be written like that. Okay? Okay. Write down quickly. Write down. Draw this one and write down. Okay. The moment of inertia of the some all the objects are getting taken the from integration, right? It's not in this case. Integration is the mathematical modules. No? It is taken using the integration, right? The I of all the objects are taken using the integration. In math, students can understand that one, but not in this situation. It's in higher education. So it's taking the I, therefore we taking the I as the formula. It is the normal formula. We taking as it is, right? We have to substitute the values and take the value like that. We have to memorize that one. I think small. ඒ කියන්නේ සමහර ඒ වගේ පොඩ්ඩක් විතරක් දැනගන්න ඕනේ. ඒ හැරුණාම ආයෙ දැනගන්න ඕනේ නැහැ. We don't need to memorize. They are given, right? I values are given, right? Okay. When you study in the integration, double integration like that, you can get the I values, right? Okay. Write down after this movement of inertia of a uniform objects. Write down movement of inertia of uniform object. Movement of inertia of a uniform object. Right. Write down Write the topic and write down moment of inertia. Moment of inertia of the uniform objects of a uniform objects are taken uniform objects are taken using integration using integration using integration. Right. Number one, right? Moment of inertia. Number one, moment of inertia of a rod, uniform rod, uniform rod, which having length capital L, which having length capital L, which having length capital L, and mass capital M, and mass capital M, which rotate an axis, which rotate an axis, passing through, passing through, normally or perpendicularly, passing through normally or perpendicularly, the end of a rod, the end of a rod, draw this one. It is given by I equals ml square over 3. It's also getting using the uh, using the integration, right? This is the axis. This is the axis. Okay, write down. Okay, write down this one only. Ml square over 3. Then number two. Then number two. Moment of inertia. Moment of inertia of a uniform rod. Of a uniform rod. Number two. Moment of inertia of a uniform rod, which having length capital L, which having length capital L, and mass capital M, and mass capital M, mass capital M, about an axis passing through, about an axis passing through, about an axis passing through the midpoint of, the midpoint of, midpoint of the rod is given by, is given by, so first we take the moment of inertia of the end. The axis is the perpendicular which passes in the end. Then now we take the center. the axis, the center, right? Like that, we can take I is ml square over 12 over 12. It's also getting used in the integration, right? In this case, we do not uh, we don't know what is the integration and what is the case, but you in after the not in A level combined maths, but after that there are double integral and other things that after that you can find the integration I using the integration, but in not in A level syllabus. A level syllabus there is no use of the integration as the taking the moment of inertia, right? Okay, write down. So this one and write down. Okay, I equals ml square over 12, right? Then write down moment of inertia, moment of inertia of a uniform of a uniform circular disc O, circular disc O, uniform circular disc O, circular disc O, solid cylinder, solid cylinder of a radius capital R, capital R, mass capital M, mass capital M, mass capital M, and axis normal to the axis normal to the plane passing through plane passing through normal to the plane passing through the center is given by the center is given by the center is given by so we can also take the cylinder, uniform cylinder, and also the circular disc. I equals to mr square over 2. Okay, write down. I equals to mr square over 2. Okay, write down. Okay, then write, then write, then write down, then write down. Moment of inertia, moment of inertia of a uniform of a uniform hollow hollow cylinder O, cylinder O, this body ring or ring or a ring or a ring. Ring mean like this. Hollow cylinder and hollow area. Mass M, radius capital R. Or we can take it as the ring. Ring is the possible. Right. If axis or ring, uh, write down the moment of inertia of a uniform hollow cylinder or a ring which having radius capital R and mass radius capital R and mass capital M capital M about an axis passing through about an axis passing through axis passing through perpendicular to the center, perpendicular or normally to the center, perpendicular or normally to the center is given I equals m r square. Okay, write down the thing. I equals m r square. Right. Okay, write down. Then you can say, then you can simply say the I is I equals m r square. When we take in the uniform solid cylinder, I equals m r square 2. Therefore, I of the hollow cylinder is higher than to the I of the solid cylinder. There, the what? Why? What is the difference? The solid cylinder having the I is lesser than to the hollow cylinder. Hollow cylinder higher. I hollow is higher. I solid. Right down. I hollow cylinder is higher than to I solid cylinder. Why? When we take in the object, when we take in the object, when we take in the hollow cylinder, the mass is around the radius. Therefore, the mass is around the radius. The mass distribution is higher than to solid solid cylinder, right? That's why when we take in the when we take in the cylinder, hollow cylinder, we can simply say the masses are around the cylinder, around the cylinder. Therefore, the distribution is around the cylinder, right? The mass distribution is higher than the solid cylinder. Mass distribution is higher than to solid cylinder. You can simply tell that. Okay. In the below, write down why the reason mass distribution is higher in hollow cylinder. mass distribution is higher in solid hollow cylinder. Right. Write down below. Write down below. When we release, when we release hollow cylinder and solid cylinder, hollow cylinder and solid cylinder, hollow cylinder and solid cylinder, uh, in an inclined plane, in an inclined plane, the solid cylinder, the solid cylinder reach the bottom, reach the bottom fastest, fast, faster than, faster than, faster than the hollow cylinder. The hollow cylinder because because I is because I is smaller, smaller in I is smaller in I is smaller in solid cylinder. When when we take in the solid cylinder and the hollow cylinder, the I solid cylinder is higher than to lesser than to the I hollow cylinder. Therefore, it is very taking the moment. The inertia mean the resistance to the moment. No? The I resistance is higher in the hollow cylinder rather than to solid cylinder. Therefore, resistance of the motion is higher than in the solid hollow cylinder. Therefore, it is taking the time to reach to bottom rather than to solid cylinder. Therefore, solid cylinder is coming first. Solid cylinder is coming first. Right. It is very important thing. Solid cylinder is reach bottom initially. Right? Right down. Okay. After that, right, we take in the IF four objects. Then five. Then five. Write down. Moment of inertia. Moment of inertia of a. Draw this one. Write this one. Then write. Then write. Moment of inertia of a uniform sphere. Of a uniform sphere. Of a uniform solid sphere. Solid sphere About axis 2, about axis 2, the center is given by, about axis 2, the center is given by, okay, the sphere, when we take in the sphere with the radius capital R, with the radius capital R, having mass capital M and radius capital R, I equals 2 mr square over 5, right? Okay, position and write down, position and write down. Okay, the sixth one, write down the sixth one. We take in the hollow sphere, hollow sphere. If the radius is capital M, radius is capital R, the mass is capital M, we can simply say, what? I equals I equal the hollow cylinder. The I is 2 over 3 m r square, and also we know the mass distribution is higher than in the hollow cylinder. Therefore, it is higher than to this one. Okay, write down, write down. 6 1. The moment of inertia of a uniform hollow sphere, uniform hollow sphere, uniform hollow sphere about an axis passing, about an axis passing to the center, to the center is given by, is given by, right, write down this one. And also we can see I hollow sphere is higher than I solid sphere. Okay, it's a normal thing. I hollow sphere is greater than the I solid sphere. Right. Write down this one and this one. And write down a sentence. Write down a sentence. The mass distribution of the hollow sphere, the mass distribution of the hollow sphere is higher than, the mass distribution of solid sphere. It is around every point. Mass distribution of the solid sphere. Therefore, moment of inertia of the hollow sphere is higher than to moment of inertia, of solid sphere. Moment of inertia of solid sphere. Right. Solid sphere. Okay. Then we move in another concept. It's also the moment of inertia. Write down the another topic. Radius of gyration. Radius of gyration. Radius of gyration. radius of gyration. Okay. What is the radius of gyration? When we take in the object, when we take in the object, let's consider like this. When we take in the object, we know what is the moment of inertia of the rod with the axis passing through the end of the rod, right? ml square over 3, right? When we take in the any object, we can simply say it it is the distribution. We rearrange the distribution of m mass with the k distance. With the k distance, we accumulate or we concentrate this mass into a one single mass, and it having a distance of k. ඒ කියන්නේ අපි මෙන්න මේ ඔබ්ජෙක්ට් එක පොඩි කරලා ගන්න. ඒ කියන්නේ මේ ඔබ්ජෙක්ට් එකේ තියෙන mass එක ගන්නවා direction mass එක ගන්නවා distance එකට k කියලා distance එක. Right? We taking the mass as k distance. K is the radius of gyration. We can simply say we can accumulate or concentrate this m into one single mass and having a distance of k. We know what is the I is ml square over ml square over 3. First we discuss that one. I equals ml square over 3. ml square over 3. Therefore, the radius of gyration, we accumulate the m in the k distance. Therefore, we can simply say I equals mk square. Why? It is the theory, no? First of all, we had discussed the I equals mk square. Therefore, these are equal terms. ml square equal over 3 equals mk square. This concept, huh? mk square. M to m cancel out. K square equals L square over 3. That means K equals L over root 3. It is a concept. Right? When we take in the object, we take the radius of gyration and the mass and the radius. Right? Therefore, we can take the moment of inertia. Right? When we take in the object, we ask what is the radius of gyration. Then we can calculate the I. Not we asking the what is the I value. Not like that. We take in the radius of gyration. If we rotate an object, we take in only the radius of gyration. We can develop the I values. Why? When we know the m value, that the mass of the object, we can take I equals mk square. Then we can take the I value. I think you can clear understand. We take in the all values. Okay. Write down the topic of radius of gyration. Write down the below it. This is the distance of the center. This is the distance from the center. This is the distance from the center of the mass. The object where mass could be concentrated. The mass of the object where mass could be concentrated without changing it without changing it. Rotational axis, rotational axis. Then write down the moment of inertia. The moment of inertia is the geometric property of a rigid body. It is a geometric. It is a moment of inertia. Write down. First sentence should be corrected like this. This is the distance from the center of the mass the object where all the mass could be concentrated its without changing its moment of inertia and rotational axis. I did not write the moment of inertia. Changing it rotational axis and moment of inertia. Moment of inertia. Write down. Then write down moment of inertia and the radius of gyration is a geometric property of a rigid body. Is a geometric property of a rigid body. Is a geometric property of a rigid body. Geometric property of a rigid body that equal to that equivalent to that equivalent to that equivalent to that equivalent to the body actual distribution of the body actual distribution of mass mass mass, right. The radius of gyration is represented by symbol k. The radius of gyration represented by symbol k. Okay, write down this one. When considering uniform road axis passing to the end of right, write down. Then what is the dimension of the k? Radius of gyration. What is the dimension? Write down. Write down this one. When considering the road, uniform road, the axis passing through rotates with the axis passing through the end of the road. Right? Write down the example. Uh, what is the dimension of k? What is the dimension of k? What is the dimension of k? K is the length. Therefore, what is the dimension? That is the dimension. Dimension of the length. What is Now, this is the radius of gyration mean the length k. K is the length. Therefore, it is the L, right? Unit of k is meter. Radius of gyration is the length. Is the length. Okay. Sometimes you can get the problems like that, right? Clearly mention that one. Unit of k is simple length. Okay. Let's discuss the previously I mentioned some radius of some moment of inertias. Okay, let's take that one. Okay, write down all the things. Okay. Okay. Write down this also. First, we had discussed the rod rotates M L I equals M L square over 3. Therefore, K equals L over root 3. Second one, we discuss the rod which rotate the center of this pass in the center. I equals M L square over 2. So find the K. K. Number 3, we discuss the cylinder, solid cylinder. I equals M L M R square over 2. Okay. Number 4. Number 4. Hollow cylinder. Find out K values. K values. We have to concentrate the mass into the K distance, right? Then find the K. MR square. Number 5, find the K. The solid sphere which having mass M, I equals 5 to MR square. Find the K value. Number 6. Number 6. I equals 3 over 2 MR square. Find the K value. Find out the K value each separately. Find out the K value each separately. In this case, it is equal, we have to equal to the M K square. We have to accumulate or concentrate this M value into the K distance. Therefore, K is L over root 2. L over root 2. Likewise, take this. I will give you a problem also. Therefore, this one is equal to mk square. Therefore, root 2. Root 2. Then also this one, k equals mk square. We can take the k as r. Then this one equals to the mk square divide the k is 2 over 5 root r. This also mk square divide, therefore 2 over 3 root r. Okay, these the values. These are the values. Okay, write down. Then we move to the example. Move to the example. Okay, write down the values. We can any object we can take the moment of inertia or the radius of gyration. Radius of gyration and the moment of inertia is the geometric property. Geometric property. Right. Your answer is correct. Okay. Do this problem. Do this problem. 7. Three masses are connected by three light weighted rod as shown. Calculate the moment of inertia and the radius of gyration of the system, but each of following axis. Each of following axis. Okay, do this one. Do this one. Do this problem. Okay. Follows are 4 centimeter, 3 centimeter, and 5 centimeter. Okay. Axis passing through A perpendicular to A, B, C. Okay. How can we find the radius of gyration and the I value? We have to take I value. The axis passing through A, capital A, that means this one, perpendicular to the ABC. That means the axis of this, like this. It rotates to 20 gram rotate, 10 gram rotate, like this. Therefore, the I value IA equals mr square. That means 20 gram into r square means 4 square. That means gram 4 centimeter square plus centimeter, that is square. 10 gram. What is distance? 5 centimeter. 5 centimeter square. 5 centimeter square. Therefore, we can take 20 into 16 plus 10 into 25. 320 plus 250. GCM square. That is the I value. That is the I value. Likewise, that is the I value. I also given that one in the answer sheet, in the cute. And also, what is the K value? We can say I equals mk square. M is the total weight. M is the total weight. What is the total weight? Total weight means 10 gram, 20 gram, 30 gram. This all summation of the that one. That means 60 gram. 60 gram into K square equals to 570 GCM square. We take in the all mass accumulating in the K distance and getting these values, right? All mass are accumulating in K distance. We get this one to the simple diagram like this. M with K distance, right? That's the case around passing the axis through A. Therefore, what is the value? What is the value? K square 57 over 6. 57 over 6. We can divide it to 1, 27 means 90. Therefore, K value equals 19 over 2. The root of 19 over 2. That means 3.082. 3.082. 3.08. 3.08 centimeters. Okay. Likewise, taking the another value, there is another problem also, no? See, there is another problem. It asking the axis passing through B and C. The axis passing through B and C. Find out it. The axis passing through B and C. Right. Therefore, uh, we have to take the axis passing through the BC. Okay. Axis passing through the BC mean we have to take this as axis. This as axis. The 30 gram rotate in around it. Therefore, the axis is BC. 30 gram pass in around it. Therefore, we can simply say I equals I IBC equals MR square sigma MR square. That means 30 gram, that distance 4 centimeter square. 30 gram, 16 gram, 16 centimeter square. That means 480 GCM square. That's the IBC value, right? IBC value. What is the radius of gyration? Therefore, we can simply say this this is I can be accumulate the distance. This is the BC axis, the mass capital M with K distance, right? Therefore, we can simply say I is the MK square. M mean the total weight. Total weight mean 10 gram, 20 gram, 30 gram. That means 60 gram. K square. I means 480. 480. That means 480. That means K square equals to 8. K square is equal to 8. K equals to root of 8. That means 2 root 2. 2 root 2. Why? 4 into 2. 4 into 2. Therefore, value is 2 into 1.14. No? 2.82 around this, that centimeter. Around in that. Okay. Do this problem also. Do this problem also. Hurry up. Do this problem also. 8. Number 8. Do this problem also. Number 8. Number 8. Okay. A cylinder rod of mass 8 kilogram, the diameter 4 centimeter, the length 4 meter. That mean it's like this. It's like this. A cylindrical rod in a mass 8 kilogram, like this. Diameter 4 centimeter. 8 4 meter. 4 meter, 8 kilogram, and diameter 4 centimeter. Comparing to the length, diameter is smaller. Thermometer, the mass 8 kilogram. Okay. Number 1, axis perpendicular to the rod passing through the midpoint. Okay. Axis perpendicular to the rod passing through the midpoint. That means second, axis perpendicular to the rod passing through the one end. Axis perpendicular rod passing through the midpoint. Calculate the moment of inertia, right? That means, first of all, we have to take the midpoint. That means, midpoint means this one. Like this. I equals ml square over 12. Right? Previously we discussed that thing also. Previously we discussed that thing also. ml square over 12. Right. What is the m? M is the 8 kilogram. L is the length. That means length means 4 meter. 4 meter. 12. 2. 3. 16. 32 over 3. That means 1 0 6 7 kgm square. Number 1, like this. Number 2, the one end. Meter. I equals ml square over 3. M mean 8, L mean 4 square over 3. That means 8 into 16 over 3. 8 into 16 over 3. Therefore, 42.67. 42.67 kg m square. Okay. Okay. The answer is correct. 10.67, 42.67. Then the axis parallel to the rod which passing through the center, not midpoint, center. Previously we had center. Okay. What is the passing through the center? That means this one. Center is this. Therefore, it is the uniform cylinder. I equals mr square over 2. M mean 8. R mean 4 centimeter. Not 4 centimeter. This is diameter. 2 centimeter. 2 into 10 to the power minus 2 square over 2. 4. 4 into 10 to the power minus 4. 16 into 10 to the power minus 4. 60 into 10 to the power minus 4 kg m square. kg m square. Okay. The values I think given are okay. That means 1.6 into 10 to the power minus 3. Okay. I think it is clear. Then we move to the another topic. Write down another topic. Angular momentum. Write down another topic. Angular momentum.